Okay, swabad. Students will be able to relate solid figures and shapes.
Net, two-dimensional shape. Plane figure, three-dimensional shape. How can you use a two-dimensional shape to represent a three-dimensional solid? Think about this question during the lesson. A net is a plane figure which, when folded, gives a solid figure. How can you draw a net for this solid figure?
How many of you understand that question or know how to answer it? Okay, Grace, what do you think?
You draw like whatever it is you want to make, like a rectangle, and then you put like the rectangles from out the side.
Okay. So when they say a net, what they're kind of doing is pretend, if you could pretend that that is a cardboard box, and you wanted to open it up because when you recycle things, you want them flat. You could take apart the sides because they're usually glued together. If you opened it up, you would have an example of a net. It would be a plain figure. It would be a flat shape. It would no longer be three-dimensional. So when you open it up and lay it out, you're going to see those rectangles that created the box. So you could see the rectangular top, the bottom, the front, the back, and the two sides. So how many rectangles or faces, rectangular faces, would create that rectangular prism? If you unfolded it, can you envision what that might look like? Hey Tyler, how many faces would there be? 6. Okay.
When might you have folded a plane figure to create a solid figure?
Can you think of any examples? I'm thinking that student council might have recent experience with this. Student council members in here? Anybody? Eli?
Last year, student council made those pennies.
Yeah, when you put together the penny for patient boxes, they probably came flat and you had to create the box.
Perhaps you folded a box when wrapping a gift or when buying donuts. The box started out flat, a plane figure, but ended up as a solid figure after you folded it.
Like pizza boxes.
Right, pizza boxes.
That's my grandma owns pizza.
Yeah.
Pizza box. So they do it a lot.
Good example, Dylan.
Have you ever completely taken apart a cereal box? If so, describe what you did and what the box looked like after you took it apart.
Okay, just think to yourself, if you would take a cereal box and open it up, take the seams apart where it's glued together and lay it out flat, what would it look like?
The box was flat after taking it apart. To draw a net for a solid, take apart the solid and open it to a plane figure. Before you begin, label the faces of the figure. Why should you label the faces of the solid figure before you cut it open?
Butch, what do you think?
So you know how it goes back together?
So you could see which are the top, the bottom.
You should label each face so you do not forget which face is the top, bottom, left, right, back, and front. Imagine making cuts along some of the edges of a solid and opening it into a plane. Think about which edges you would cut. Open the box along the edges. Should you cut all of the edges?
I was just going to ask that. What do you guys think? Would you want to cut every edge? Olivia? Why not? It would. You would have lots of pieces and it wouldn't be connected anymore.
No, you do not want to cut all of the edges. You want to cut so all of the faces remain attached to each other. How do you know how many edges to cut?
What do you think, Grace?
This is a random guess, but half of the faces they have.
Half of them?
You cut one edge at a time and open up the figure one face at a time until the figure is completely flat. Unfold the box and lay it flat. This is the net for the box.
So they just created a net. They cut on the edges and opened the faces up, and this is what that box would look like.
What shapes do you see when you unfold the box?
What shapes are they, Hope? Rectangles.
The net contains 6 rectangles, since the original solid contains 6 rectangular faces. Do you think this is the only way to cut open the box?
Corinne?
No, because you could have cut it the opposite direction.
Okay, so the net might look different if you cut it a different way.
No, there are other ways to cut open the box. See if you can determine a different net. Now you know how to use a 2-dimensional shape to represent a 3-dimensional shape.
Okay, let's just look at a couple of these together. What do you guys think? This is the net. If you folded the sides up, what 3-dimensional solid object would it make? Tyler. Okay. Do you guys agree? Look on, turn back to lesson 13:1. It has a square bottom. You can see the square, and it has 4 triangles. So because each of the edges of the square have a triangle connected, so they're going to come up to one vertex at the top. So what shape would that be? A pyramid, right? Okay, these all look like squares. What do you think this net is going to create? Kirsten? A cube. We could also say rectangular prism because a square is a rectangle. So we could say cube, which is more specific because a cube has to be all the same, but it's also a rectangular prism.